We're doing inverse relations and functions. Inverse functions are extremely important because that's how you solve things. How do we solve the square root problems? By doing the inverse function, squaring both sides. When you have x plus 2 equals 3, how do you solve it? By doing the inverse and subtracting 2 from both sides. Inverse functions undo each other. That's the whole idea behind an inverse function. They undo each other. Inverse notation. If f of x is the function, f to the negative 1 power is its inverse. That's what that means. It's the inverse. It's slightly different because it's part of the function notation. X to the negative 1 is 1 over x. F to the negative 1 is not 1 over f. It's the inverse notation. It's because of where it is in the function. Okay, it's part of a function notation. The reflection line is the line y equals x. We will be using that later. It's an important line. Do you remember which one it is? We will be using it later. Function test, we've done this, a vertical line test. If a vertical line to be drawn such that it passes through 2 or more points, the relation is not a function. We did that in the vertical line test, passing a ruler over your function, over your graph. If it crosses more than once, it's not a function. We did that. I think, chapter 2. So that's not something new. Okay. So here we go. Now, finding functions. Yes, ma'am. Go back. Yeah, I'll go back. Yeah, that bottom part, you guys. Yeah, it was kind of covered up. Okay, so first thing you want to do is plot those points. Just go ahead and plot those 3 points that are there. 1, 2, 3, and 2, 1, and 0, -5. So those are the points you're doing. And you want to find the inverses. Now pay close attention. Pay very, very, very close attention. Here's how you do the inverses. The inverse of the 0.43 is the 0.34. Beautiful. The inverse of the point -2,1 is the 0.1, -2. And the inverse of the point 0, -5, -5, 0. Ooh. You're way ahead of me. Oh, yes, but kids still miss this on the test. Like I said, this is literally one of the easiest things we do, this part here. It gets harder in a little bit. But this beginning stuff is really easy, and I should just be able to skip grading those on the test, but I don't because I know kids will get them wrong. Now, please, do me a favor, plot these points as well. One, two, three. 1, 2. Oh, they're not -4. Yeah, something wrong. 1, 2, 3, 4. There we go. That's what I'm looking for. 1, -2, and -5, 0. Now, the reflection line. Remember the reflection line? The reflection line, y equals x. Go ahead and sketch the reflection line in here on your graph because I want to show you something about inverses. Whoa. Yeah, if you sketch your reflection line, notice the points and their inverses. They have a relationship. They are reflected across that inverse line, parallel and the same distance from each side.
It looks like modern art. Doesn't it? Like in a coffee shop or something.
Okay, that's what inverse functions do. They reflect it across that reflection line. All graphs, all representations of a function, whether it's points or a line or anything, they reflect across that. And that's what inverses are of each other graphically represented. They will always be that way. And so that is one of the ways you can do and find these is to find the one that matches it on the opposite side. Same distance away, perpendicular to it. Same way across. Find the one that matches it across. Okay, please plot those. Find the inverses and plot them. You don't need to do everything I just did. I did the inverse line more as an illustration of what's going on than anything else. Nope, I didn't pause it or anything. Okay, not a big deal. So the inverse of the point 0, 2 is 2, 0. The endpoint of negative 5, 0 is 0, negative 5. And so I'm going to go ahead and do 0, 2, and 2, 0, and negative 5, 0, and 0, negative 5. I went and plotted the original and its inverse. Now, this next part is where you need your pencils for. Okay, and unfortunately, I cannot show this on the screen because I am not strong enough to fold the smart board over, and even if you did, you'd break the thing anyways. Okay, so I do have a smaller version. I'm going to leave this recording so I can hear at least the instructions. Okay, so I do have here a smaller version of the graph to show you. I'm sorry I can't make it any bigger than this, but you don't really need to do it. So the paper fold method. Here's what you do. The first thing you do is you take your pencil, and I'm going to use a red pencil, and it does work. I tried it. Red pencils will work. And I'm using red so it makes it easier for you to see. Take your pencil and trace over the graph. So you have this parabola here. You're going to trace over it. The more you put down on there, the more you put on there, the better this is going to work. So rub, 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 rub. Take that pencil and rub right over it. Once again, if you need a pencil, I have some on my desk. What you want to do is you want to lay down. You want to lay down some of that graphite because we don't use lead anymore. In order to make it work. Now, here is the most difficult part of what you're doing. You need to fold your graph over. But the line that you're folding it on, the line that decreases is the line y equals x. This is the line you're folding it on. You need to fold it on that. You need to fold that as straight as possible. Yeah, no, it's not easy. So, see what I'm doing here? Let's see. There you go. Get all lined up.
I think it's fine.
Now, okay, keep it folded over once you do that. Keep it folded over once you do that. And then what you do is you take your favorite burnishing tool. Those of you in art class will know what I'm talking about, a burnishing tool. My favorite burnishing tool is my thumbnail.
Oh, fancy.
And you rub where the original graph was. Rub, rub, rub. You're burnishing using burnishing. Rub, 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 rub. Rub, 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 rub.
See, I took this class last week.
And you unfold it, and it shows up on here a little bit. Let's see if I can get it better. So after you've done it for a while, unfold it, and you can see where it transferred over. And then I always trace it.
What do you mean? Yeah.
If you would follow it. What?
It's just getting tired.
Dude, I literally my own.
Okay. And there's your inverse function. There's your inverse graph. The more pencil you put down when you begin, the better it's going to work. The harder you rub, the more you rub, the better it's going to work. Okay. The most common error that students make, guys, the most common error that students make is not folding it across that correct line. You have to fold it across the line of reflection. That is on the test. That is the most common mistake students make. It's not folding on the line of reflection. Okay. So yeah, this is what you got. This is what it will look like when you're done. Okay. So on the graph, and I will post these. It'll end up looking something along these lines here. That's not exactly what you get. I will have all of them posted. So go ahead and do the next one, the one that matches this one. Give that one a try. Make sure it works. Once again, put the pencil lead down.
Get your variation tool.
Yeah, if you're in art, that's an art term. A burnishing tool, that's an art thing. Yeah, what I do to get my fold right, I hold it up to the light and I look through and make sure the corners of the grid line up. It's kind of what you have to do. There's not a lot of other things. The other way to do this, and I have done it, if you take a ruler and you put a ruler across where that line is laid down and fold it over on top of your ruler, that'll work too for a line. And then rub, 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 rub. Rub, 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 rub. Rub, 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 I guess this red pencil is working out pretty well. Okay, now, if your graph is made of straight lines like this second one is, you can actually graph using the inverse points your inverse function. Now on the test, it's going to be all squiggly crap, so this won't work on the test. But if you have this situation, what you do is you just plot the inverse of the points. So this point here is 1, 2, 3, 4, negative 2. So I go negative 2, 4. Yeah. Negative 2, 1, 2, 3, 4. And then I go, this point here is negative 2, a little more than 1. So if I go, or sorry, yeah, a little bit less than negative. So negative 1-ish, negative 2, almost negative 2. So it'd be almost negative 2 on the y, about negative 1-ish here. No, that's not right. Negative 2 on the y, negative 1-ish on the x here. So there's that first segment. And then this one's 1, 2, 3, 4, negative 4, negative 1. So I go negative 1, 1, 2. Yes, I go down. Thank you. Oh my God, I'm blowing my negatives. Pause. 1, 2, 3, 4. There we go. And there's the second part. And this is negative 5, 1, 2, 3, 4. So I go -5, 1, 2, 3, 4. Is that right? Yeah. There's that. So you could do that if that's what you want to do if it's all straight lines. But that only works if it's all straight lines. So if you got curves to it, it's a little harder. I'm going to tell you right now, the one that tests all squiggly, it's all get out. It's doing this isn't going to work on that. But it is another possibility. Okay.
What would you say that looks like?
I don't know. I'm not into Rorschach tests.
What's that?
You know where they show you the thing. Ooh, what do you see in this ink blot? That's a Rorschach test. Okay. The answers for these will be posted. I'm not going to deal with them right now. Now we get to the difficult part. Find each inverse algebraically. So, my original function, f of x, is 3x plus 5. To find the inverse, your first step, and your first step is already done for you here. Your first step is to replace f of x with y. And then what you do is you solve that equation for x.
Yeah.
You rearrange it and solve it for x. Subtract 5 from both sides. Y minus 5 equals 3x. Divide both sides by 3. Y minus 5 over 3 equals x. My inverse function. Swap the x and the y back. That's my inverse function. X minus 5 over 3. That's how you find an inverse function.
Dude, this is a fun one. For real. I like this.
It is the more difficult method of doing it, but if you have an inverse. Now, my top kids do this at the beginning of the year to review, prepping for the class. Chapter 1 is all review of stuff before. They do the same thing. Their subject matter tends to be a little more difficult than what they solve for. And sometimes finding the inverse algebraically is a real pain in the butt. And sometimes you can't even do it. You got to be able to separate the variables out. Sometimes you can't do it. Okay. So with this one here, same idea. First step's already been swapped. Now I want to solve this one. Add 2 to both sides. Y plus 2 equals 1/4 x. How do I get rid of the 1/4? I multiply both sides by 4. Because 4 times 1/4 gives me 1x. And then I multiply 4 times y plus 2. I get 4y plus 8. X equals 4y plus 8. So what's my inverse? My inverse is 4x plus 8. Okay. Next example, same idea. First step, add 1 to both sides. Y plus 1 equals 2x squared. I want to get rid of the x squared, but my first thing I'm going to do is I want to get rid of the 2 first. I don't want to take the square root yet. So I divide both sides by 2. Let me move this down out of the way. So I get y plus 1 over 2 equals x squared. And then I square root both sides. So I end up with, oops, pardon me. I get x equals plus or minus the square root of y plus 1 over 2. Now this is kind of important here. When I do square roots solving, I have to include plus or minus. If I do this one here, I get plus or minus the square root of x plus 1 over 2. If I don't have the plus or minus, I don't have my full inverse function. Let's go back a second to where we did the graph of the inverse here. The original function gave me this full parabola. If I don't use plus or minus, let's say only do the positive part, that only gives me this part of my inverse. It doesn't give me the full inverse if I don't do plus or minus. It only gives me the positive square roots, which only gives me the top half of my graph, which is not a full inverse. That's only half of the actual inverse function. I need to include both parts to do my inverse. I need to include both the plus or minus. If I'm taking the square root, I have to include both the plus or minus in my square roots. Okay? Or it doesn't work. Back to here. And this last one is actually even easier. Add 1 to both sides. And I get y plus 1 equals x cubed. Take the cube root of both sides, and I get the cube root of y plus 1 equals x. So f inverse is the cube root of x plus 1. And I hear some of you saying, but Mr. Orris, why didn't you use plus or minus? Because a cube root can be positive or negative depending upon what's underneath. You don't have to worry about doing it. It doesn't always come out positive. If you have a negative number underneath, it will come out negative anyways.
That which were all on different, right?
Yeah, yeah.
Shouldn't be the cube root of y plus 1?
And up here, yeah, I started to write x just out of habit. That's a y there. But it should be x plus 1 in my image. The answer should be x because if I'm doing a function of x, I need to have x be here. And my inverse is that. The only reason I introduced y at all is strictly for doing algebraic manipulation. My final answer should be an x just like my original one was. Okay. Your inverse and your function and its inverse need to be essentially the same variable. Now, there is something about inverses that I want to show you. So we'll go back to, I'm going to go back to this one here. 3x plus 5 and x minus 5 over 3. So if I go back to these, 3x plus 5 and x minus 5 over 3. These are the first inverse functions we got. When you have an inverse function, the composition of each other will always give you x. If I take f composed of f inverse, in other words, 3 times x minus 5 over 3 plus 5. If I do that, solve it out. 3 times x minus 5 over 3, that's x minus 5, plus the 5 still behind, I end up getting x. If I take f composed of its inverse, I get x. If I do f inverse composed of f, in other words, I take 3x plus 5 minus 5 over 3 and solve that. 3x minus 5 plus 5 is 3x over 3 gives me x. Look what I got for both of them. If I take a function and stick it into its inverse, and if I take an inverse and stick it inside the original function, and I simplify, if I did it right, this is what I always get. I get x. An inverse of a function and the function of its inverse composed of each other will always come out x, no matter what. If you get it right, that happens. That's what happens with inverses. And by the way, the question for my AP Calculus students on the test would be, find the inverse, and then they would have to do this to prove that it is the inverse. You don't have to do that. You just have to find it. Okay, find the inverses. Okay, first one, solve it out, subtract 3. Y minus 3 equals negative 6x, divide by negative 6. And my inverse ends up being x minus 3 over negative 6. On the next one,
Wait, you can't simplify that?
no.
Oh, because the
Yep. Subtract 1 from both sides. Y minus 1 equals 2/3 x. Multiply both sides by 3/2. And this gets kind of interesting. The way I would write my final answer on this one would be 3x minus 3 over 2. I would distribute the 3 and then put everything over 2. That's what I would do. It's the cleanest way to have it. It looks the cleanest that way. Okay. Alternatives. If you had 3/2 x minus 3/2, that would be okay too. So what I did is I just combined them up into one fraction, common denominator, combine them up into one fraction. It looks a little neater that way. Okay. If you gave me something else that was equivalent to that, I would be okay. I wouldn't mark it down. On this one here, add 2 to both sides. Y plus 2 equals 5x squared. Divide by 5. Y plus 2 over 5 equals x squared. Square root both sides. And I get plus or minus the square root of x plus 2 over 5. Do not worry about rationalizing the denominator. Technically you should, but really it doesn't matter at this point.
It's fine.
The last one, this is actually really easy. Divide by 7. Y over 7 equals x cubed. Take the cube root. So I get the cube root of x over 7. Any questions?